Hello everyone. This is one more algorithm for pattern searching or string matching, and the name of the algorithm is KMP algorithm. It is basically used to find the pattern inside the large text, whether the pattern is available inside the text or not. If it is available, then we'll return the index number. So let us start our today's video on KMP algorithm for pattern searching or string matching. The basic idea behind this algorithm is to build using the prefix and suffix information of the pattern. So when we compare our pattern with the text, at that time we are using prefix and suffix information, and based on that we will compare our pattern with the text. And this is the logic of KMP algorithm. So before starting off the KMP algorithm, you must know how to find a prefix and suffix of any pattern or any string. So let us take a different example. Suppose our string is A and B. Our string has a two character A and B. Then the prefix and suffix of A and B string is A is before the B, so that the prefix is A, and B is after A, so that the suffix is B. If only two characters are there, then first character will be prefix and second will be suffix. But whenever three characters are there, at that time what is prefix and suffix? So the prefix of ABC is A and AB. This is the single character A, and the pair of character AB, these both are the prefix because it is available before the C character. Now if you want to find the suffix, then it must be after, so that after A we have a two character B and C. So we have to use for single character is C, so C is a suffix, and the pair of character BC, it is also suffix. So the prefix is A and AB, and the suffix is C and BC. If more than three characters, or we can say four characters are there, then we can say before D we have a three character A, B and C. So based on that we have to identify prefix. So prefix is single character A, then after pair of character AB, and three character in a pair, that is A, B and C. So these all are the different prefix, and suffix of this A, B, C, D is after A we have a three character B, C and D. See, the single character D is a suffix, pair of character CD is a suffix, and BCD is also suffix. So in this way we have to identify prefix and suffix information of the pattern, and this information is very important in our KMP algorithm to shift our pattern when we match our pattern with the text. So let us understand first different steps of KMP algorithm. So now let us discuss different steps of KMP algorithm. Step number 1, find out prefix array or pi table of the pattern. So we have a set of character inside the text and some character inside the pattern. So the first step is we need to identify prefix array or pi table of the pattern. Step number 2, use pi table as a reference for shifting the pattern for matching with the text. When we compare our pattern with the text, then we need to start from the location number 0, or we can say 0th index. And as per the new method, we are just shifting our pattern by 1. But here we are not shifting every time by 1, but we have to use pi table as a reference to shift the pattern to match the character with the text. Step number 3, when all character of the pattern match with the text, use following formula to find out the index number. So formula is I minus length of pattern plus 1 will give index number where our pattern is matched with the text. So these are the different 3 steps we need to follow when we apply our KMP algorithm to find the pattern inside the large text. Let us take one example. In that we will use these 3 steps to find out whether our pattern is available inside the large text or not. Once it is available, then this last step will return index number. Let's take one example. In this example, suppose we have a large text capital T. In that number of characters are there, and we have one pattern capital P which has some character. Here total 7 characters are there inside the pattern. Now we need to identify whether this pattern is available in this text or not. If it is available, then we need to return the index number. So let us start by using KMP algorithm. So as per the KMP algorithm, our first step is we need to identify prefix array or pi table of the pattern. Right. So let us find out pi table of the pattern. So as per the first step, initially we put 0 in 0th location. So in our pattern total 7 characters are there. Our first character is on 0th index, second will be on first index, third will be on second index, like that. So we have to put initially 0 in 0th location. So we have to just put here 0 because we have only one character A, and A itself is a suffix and itself is a prefix. So only single characters are there, so that we have to put 0 here. Now our next step is we need to consider first character and second character. So we have a pair of character. Now we have a two character A and B. So find out all the suffix and prefix of this pair of character A and B. So the prefix is A and suffix is B because we have a two character. So the first character is a prefix and second character is suffix. Now we need to verify whether both this suffix or prefix is equal or not. Whenever it is equal, then we need to identify the length. But here both are not equal, so that we have to put 0 there. Now we need to consider third character. So we have 3 character now in a string, that is our A, B, A. Now find out all the prefix and all the suffix. So all the prefix of A, B, A is A and a pair of character, that is AB. So A is a prefix and AB is a prefix. Find out all the suffix. So a suffix means after, so that after A we have a two character B and A. So the first suffix is a single character A and second suffix, that is a pair of character B, A. Now from this all the values of prefix and suffix we need to identify the common one. So here A is a common in prefix and suffix, this AB, and here is a B, so this is not the common. So only one string is common, that is the first A is a prefix and A is a suffix. So the length of matching prefix suffix is equal to 1, so that we need to put 1 here. Now we need to consider total 4 character, that is our A, B, A, B. So we have now a 4 character AB, AB. Now find out all the prefix and suffix. So prefix means before the character. So before character B we have a 3 character A, B, A. So find out all the prefix. So we can write single character A is a prefix, pair of character AB is a prefix, and ABA is also prefix. Find out all the suffix. So after A we have a 3 character B, A, B. So all the suffix is first single character B is a suffix, then single character B is a suffix and pair of character AB is a suffix, and ABAB is also suffix. So now these all are the prefix and suffix. We need to identify which one is common. So here A and here B, so not common. Here A and B, AB, and here AB, so this is the common, or it is available in both prefix and suffix. Here ABA and this is our BAB, so it is not common. So we have a 2 character in prefix AB and the suffix AB. These both are the equal, and the length of this equal, or we can say the common string of a prefix and suffix is equal to 2, so that we need to put 2 there. So we have to put 2 here. Now we have a different 5 character A, B, A, B, then next one is A. So we have a total 5 different characters. So find out all the suffix. So before A, we have a 4 character A, B, A, B, and after A, we have a 4 character B, A, B, A. So let us find out first of all prefix. So before A, we have a 4 character A, B, A, B. So first we need to consider first character, that is A. Then after second pair is AB, third one is ABA, and fourth one is ABAB. So these all are the different prefix. Now we need to identify suffix of this string. Suffix means after. So after A character we have a BA string. So as per the suffix rule, we need to identify, we need to write all the suffix. So we have to start from the last character, and this last character is our suffix. Then pair of character BA is a suffix. Then ABA is a suffix. And BABA is also suffix. So now out of this all the prefix and suffix, we need to identify the common one. So A is common in prefix and suffix. So here AB and BA, this is not common. Here ABA and here ABA is also common, and these both are not the common. So we have a 2 pair, that is A is common in both prefix and suffix, and this ABA is common in prefix and suffix. So we need to identify the common set of character which is available in prefix as well as suffix, and which is a larger one. So among these two, this ABA is a larger one and has a total 3 different characters, so that we can say the length of the matching prefix suffix is equal to 3. So that we need to put 3 here. So just put 3 here. Now our next character is a D, so that we have a set of character like AB, AB, AD. So find out all the prefix and suffix. So the prefix is before D we have a set of character like AB, ABA. So we can have a prefix like a single character A, then after pair of character AB, then after ABA, then after AB, AB, and last that is AB, ABA. Same way the suffix is, we need to start from the last character, that is a D. The first single character D is a suffix, then AD is a suffix, BAD is a suffix, ABAD is a suffix, and BABAD is also suffix. We need to identify the common inside the prefix and suffix. So just check. A here D not common, AB here AD is not common, ABA and here BAD not common, ABAB here ABAD, this is not common, here ABABA and here BABAD, this is also not common. So that we can say the length of the matching of prefix and suffix is equal to 0. So that we need to put 0 here. Now the last character, so our string is ABAB, ADA. So find out all the prefix and suffix. So all the character before the A. So here last character is A, and before that we have a set of character like AB, AB, AD. So that the single character A is a prefix, then a pair of character AB is a prefix, then ABA is a prefix, ABAB is a prefix, ABABA is also prefix, and ABABAD is also prefix. Find out all the suffix. So after A we have a set of character like BABADA. So that we need to start from the last character. So A is a common, and we can say A is a suffix, then the pair of character DA is a suffix, then after ADA is a suffix, BADA is suffix, ABADA is suffix, and BABADA is a suffix. Find out all the string of prefix and suffix, and we need to identify which one is common. So A is a common in prefix and suffix, AB and here DA, this is not common. Here ABA and here ADA, this is not common. Here ABAB and here BADA, this is not common. Here ABABA and here ABADA, so this is not common. Here ABABAD, here BA, BA, DA. So these all are not the common, only one character is common, that is A. So that we can say the length of matching prefix and suffix is equal to 1. So that we have to put 1 here. Now after this step we have a final prefix or pi table. So this is the pi table, or we can say the prefix table. Now use this table to shift our pattern when we match our pattern with the text. So just see how we can match or how we can shift our pattern with the text. So step number 2 says that use pi table as a reference for shifting the pattern for matching with the text. So we need to start, let us start to match our pattern with the text. So we need to start from the 0th index. So this is our text and this is our pattern. So let us compare our first character of text with the first character of pattern. Here it is B and here it is A. So matching is not found, so that we need to shift by 1. Here I indicates the index of our text and J indicates index of our pattern. So we need to just shift by 1. So next we will compare our A with A. So both are equal. Once these both are equal, then we have to increment index I. So I will be on 2 and J will be on 1. Now we need to compare D and B, whether both are equal or not. So here B and D both are not equal. So whenever both the characters are not equal, at that time we have to refer our pi table, and according to the value of pi table we have to shift our pattern. So before that we have to perform a backtrack here on our pattern. So we have to just go back. Our previous value is 0. So we need to verify the value on index 0 on our pi table. So this is our pi table, and on index 0 the value is 0. It indicates that we have to compare our D character, or we can say the index number 2 of our text, with the 0 character or 0th index of our pattern. So we have to compare D with A again. So D and A both are not equal. It means that again we have to perform shift right operation. Once we perform shift right operation, then we have to compare B of text with the A of pattern. So B and D again both are not equal. So we have to perform again shift right operation. Then again compare A of text with the A of pattern. So A and A both are the equal character. Then compare next two character, B and B both are equal. Then again A and A equal, B of text and B of pattern both are equal. The next character A and A both are equal. Then here B and D both are not equal. It means that index number 9 of our text and the value is B, and index number 5 of our pattern and the value is D, both are not equal. So we have to again perform backtrack. We have to just go back. Our previous value is 4. So we have to check our pi table on index number 4. So in our pi table, this is our pi table. On index number 4, the value is 3. It indicates that we have to compare value on third index of our pattern, that is B, with our current value of I, that is 9. It means that B. We have to compare a third index of our pattern with ninth index of our text. Accordingly, we have to shift our pattern. So we have to shift like that, and we have to compare ninth index of our text with third index of our pattern. So we have to compare B with B, both are equal, A both are equal, D both are equal, A both are equal. It means that all the characters are equal. It means that matching is found. Once all the characters are equal, then we have to follow our last step, that is our step number 3. We have one formula to identify the index, and the formula is I minus length of pattern plus 1. So I is equal to, currently the last value of I is equal to 12, and the length of our pattern is equal to 7 plus 1. So that total is 6. It means that our pattern is available inside the text on index number 6. right? So this is the pattern which is available inside the text. So in this way we can identify whether our pattern is available in this large text or not. Now let us discuss algorithm. As per the KMP algorithm, we have to pass a set of characters, or we can say the text as an argument and pattern as an argument. Now we have to take one variable, and variable j is equal to 0. First step is we need to identify length of our text, and it is suppose known as small n. Then identify length of our pattern, and it is known as, for example, m. Next step is we need to generate one prefix table, as we discuss how we can generate a prefix table. So generate prefix table. Then take one for loop starting from I is equal to 0 to I less than n. Inside this for loop, one while loop is required to compare a character of pattern with the text, and this loop will be executed until a character of pattern and text both are equal. Once both are not equal, then we have to perform backtrack, and we have to prefer our pi table or prefix table. Based on the value of a prefix table, we have to shift our pattern. Again, we have to compare character of pattern with the character of text. Once we reach j is equal m, it means that once we get a whole pattern inside the text, then we have to write a pattern is present, and we have to return index number based on this formula, that is I minus m is equal to I minus m plus 1. This m is nothing but the length of our pattern, and I is the current index of our text, and based on that we can get the index number. Then again we have to refer our prefix table. We have to go back, perform backtrack, and refer our prefix table to check whether another occurrence of the pattern is available inside the text or not. So this is all about KMP algorithm to find all the occurrence of pattern inside the large text. So this is all about. Thank you for watching this video.